Excellent. Okay, everybody, welcome to this week's seminar. An announcement before we get started. So this is just a reminder that starting next week, we move to our fall schedule, which will meet an hour later than normal. So right now we're starting to meet at 2 p.m. Eastern Daylight Time. Starting next week, so on the next seminar, we'll start meeting at, excuse me, 3 p.m. Eastern Daylight Time. So Eastern Daylight Time. So we're just going to shift ahead an hour to help accommodate some schedules. I know there are people who wanted us to actually move earlier. Some people wanted us to go later. We had to make some people unhappy. Story of my life. Good. Otherwise, usual ground rules apply. If you have a question, just unmute yourself, break in, and ask your question. Gabriela will go for an hour, and then we'll leave the stream on afterwards for follow-up discussions and questions. Otherwise, Gabriela, go ahead and take it away.
Yes, please. Thank you. Thank you for having me. Well, this is a work on with two more co-authors of mine, Jon Strand and Sole Siddiqui. And this is, how the title indicates, the effect of carbon pricing on international trade and carbon emissions. So this is more or less my my outline of the presentation today. I'll try to use my hour efficiently. And so let me give you some background to this. The international shipping activity faces no any type of tax, especially on emissions, carbon emissions. So I think the state of this situation is that what will be the consequences of that? It is that are they optimally using the routes that they take? Are they using the vessels with optimal technologies? Are we transporting efficiently the goods that we need to transport, and how much do we transport them? And of course, not having any tax on emissions also incentive this sector to consume too much of this fuel. And that, of course, especially in the maritime sector, the fuels are very polluting. And the third thing, the consequences of not having the tax is a lack of, we are missing the opportunity of obtaining some fiscal revenues from these taxes, which can be very well used to compensate the developing countries, and also the countries themselves can help themselves to obtain more fiscal revenues. That is most of the time is the main problem that they have. The difficulties to collect enough fiscal revenues. So as I said, that so not to have a taxation affect what vessel, in the maritime sector at least, what vessel you will use, whether you should not transport your goods by airplane, but rather by boat. And the other thing is the structure again on the trade, the use, and also the discourage perhaps advancing the technology, because when it's cheap to move around, then why you can go whichever vessel you want to travel, and then you don't advance the technology. So let me tell you another background to this sector. We focus here on the maritime sector. So 90% of the revenues obtained in the maritime sector come from transporting goods. In comparison to the aviation, only 15% of the revenues come from transporting goods. Another piece of information has a background to this work is the fact that the maritime sector contributes to around 2.5 or 2.6% of the global CO2 emissions. Aviation is similar. And the maritime sector, it contributes to 51% of the total international trade. The aviation contributes to 20% of these total emissions from international trade, and road and rail contributes 22% of this total emissions that come from international trade. As I told you, we focus only on the maritime sector. So a little bit more of background to this work is that the International Maritime Organization has said, because as a result of the Paris Agreement, and they are telling them that, well, the emissions are too high, so they are pressing them to establish some goals. So they have proposed to reduce their carbon emissions by 50% of the levels of 2008. And that corresponds to a little over 1 billion tons of CO2. Another thing they have been trying to do, or they have already established, in 2017, they have a new rules about the technical efficiency of the vessels that they need to follow. So they are building, you can say, new vessels more efficient. And in 2020, just this year, they have a new rules for the content of sulfur in the bunker oil. The bunker oil is a very polluting oil. It's almost what they say is the residuals of all possible oils you can imagine in the world. So that's what it becomes a bunker oil. So it's very polluting. So, but there is no discussion about carbon taxation, not any type of carbon pricing. So, what is it that we want to, some specific questions we want to answer in this work? And how do we attribute responsibilities to countries and prototypes to carbon emissions? The second is we want to measure how much these carbon emissions can be reduced by introducing a carbon tax. And the third thing is we are estimating how much revenues or fiscal revenues can be collected by country. And hopefully one can imagine, like the IMF proposes, right? To have a fund where this money can be collected and then distributed to countries that are most affected, especially developing countries or countries that are isolated or islands, you can say. So these are basically the question that we attempt at least to answer, right? So as you know, we don't have carbon taxes today. They are not implemented. So, so what we try to do is to say, well, when we have the bunker price, so we are trying to simulate or emulate, if you want, that the effect of changes in the bunker price could reflect or will be similar to imposing a carbon tax, right? Because again, we don't have carbon taxes now. So we have to, in order to calculate these carbon emissions and the effect on trade, we have to try this type of assumption. Now, what data do we have? I will come a little later on specifying the data that we have, but in
can I interrupt for just a second?
Yes.
So is there something special about emissions from international shipping versus emissions for domestic shipping, or is it, is there something special about that?
Yes, it's the type of, first of all, it's the type of oil that they use. It is very polluting, but also the contribution is almost 50%, 50% of total international trade emissions come from the maritime sector.
But I guess I was thinking about the paper that Sam presented at the beginning, and in some sense, if we think about putting the tax on the products that are coming in,
yes,
wouldn't that kind of wouldn't that treat international shipping and domestic shipping in kind of an equal way, and you wouldn't have to do anything differently?
Yes, but what criteria would you use to tax this product? Which are the most emitters?
You still need to measure the carbon content of each good, and it's going to depend upon the mode of transport. It just, should it be on the shipping or should it be on the product that uses the shipping?
Yes. Well, the problem is not having a global carbon tax. This is the problem not having then I guess you will have to shift around. Where are you going to? Yeah, I guess that's a good question to do it by product.
And then sometimes it would be thought of as the buyer of the product has the tax on its own products, and when it imports, it imposes a tax. And then I guess you would want to have the carbon content of the product include this shipping, the carbon embodied in the shipping of the product.
Yeah.
And I guess with a kind of import, you know, a border adjustment like that on the imports, I think George would be right that that would be one policy where you didn't have a global carbon tax, but you sort of did it by the destination.
By the carbon content. I think that's a good point. I will, yes, sure. Maybe I should, there will be another paper, right? Actually, to show that. So what will be the carbon emissions and the incentive to reduce? And I will show you how striking the difference are in the carbon emission. That's a good point that you made. Thank you. So because there is a big difference on the amount of emissions of these products, you know? So
yes.
Is
there sort of a rough number one? I'm sorry, I came in late,
you
might have said this, but is there kind of a rough number on manufacturing goods that are imported, the fraction of the carbon content that would be in the shipping versus in the goods?
I will come to that. I will estimate that.
Okay.
Yes,
okay.
I will estimate, and you will see, and now you will perhaps this argument of yours will be even more enforced because oh, you see, look at this good, how much carbon emission you have there. Maybe we should address those problems, you know. So I will show you the numbers. Okay, so we focus a little bit what George takes. So I partially do. We partially do what George is pointing out. We focus on the heaviest products. And of course, the heavier the product, the more carbon emission they will emit. So it is a little bit more general to George's comment, but at least we take the heaviest products, right? Which is really, yes. So, but it is a striking result that we get. Okay, so more here. So again, we focus on studying the effect of carbon tax on the structure of trade, but just remember that our left-hand side variable, both in the so at least empirical way, is the weight times the distance. You know, and as I go, I will demonstrate to you why this is important. You know, both from the economic point of view, but also practicality. So I also do the pass-through of carbon price to the price, to the exported good, right? I'm not so sure if I have time to present that, but I have results on that too, and it's in the paper. The third is that, of course, we estimate, as I said, I think I'm repeating myself here, I'm sorry. Calculations of the emissions on the trade by type of product. And of course, again, the fiscal finances that can be obtained. So let me just briefly say, you know, we have some kind of relationship with gravity models, but remember that again, we are studying weight time distance. You know, that's perhaps the most crucial difference from the gravity models. And we do study the progress at the 6-digit level aggregation. And here, that means that in our theoretical model, the firms choose not only the quantity, but to which country to export. As I said, it's also very useful for us to have the elasticity of the weight and distance with respect to the changes in the bunker price, because the data on carbon emissions that we have from the OECD is by vessel, and each vessel is specialized in different type of products, and that data only has the carbon emissions per vessel and product type. I'm sorry, the carbon intensity of these vessels and products and ton kilometers, you know? So that is what is useful for us to have also, to have elasticity of weight times distance with respect to the boundary price. Okay, so I'm sorry that this slide is a little long, maybe overpopulated, but I just want to say briefly, these 5 papers are the ones that are closest to this work. And this Christea work you may be familiar with, they estimate, they don't do any econometric work. None of this work does any econometric work except some work for Brancaccio. But Christea uses the GTAP to calculate for 2004, for only 1 year, the emissions from international trade. Shapiro uses, calculate also for 1 year. His main objective is to calculate what is the effect of a carbon tax on welfare. So they use data from US and Australia, and some estimation from GTAP, and they assume one single carbon emission intensity of 9.53 grams per ton of CO2. Okay, so I will show you that I disaggregate, I have more data to attach a carbon intensity for each type of product. The SHIM is a nice paper in the sense that they are following each vessel and try to estimate what product they are. Sorry, so they have a mapping of all the vessels traveling to Brazil, to the rest of the world, and map how these ships or these vessels are traveling, or which product are they transporting. And from that data, they try to estimate more or less what is the carbon content of this transport. Perry simulates or calibrates a model to calculate how carbon emissions will be reduced for different types of carbon taxation. And Brancaccio is, the co-author has 2 papers on evaluating how trade is affected by changes in the oil price and transportation costs. And the elasticities are quite high, actually. So, but the data is very small. It depends on the shipping contract that is relatively small, and that they follow this AIS system to track the vessels. Okay. Okay, so let me just move to my theoretical work. Let's see how much time. Okay. So our data is at the country basis. We don't, but I will tell you when I end up with the final solution of the model. I think if I have the data, I can apply also for firms. Okay, so the theory, one can say that you can use it at the firm level, but you can use it also at the country level. And I will try to convince you that that is possible. Okay, so but at least it's a bottom-up construction from the individual consumer and individual firms, and try to obtain the aggregate trade from that behavior, those individual behaviors. So that implies also that we move away from Harmington and Shapiro paper that they assume that there is only one variety per country. So remember that we have, I would like to have the 8-digit, I don't have, a 6-digit level or level aggregation. So let me see. So let's talk about the demand side of this model. So we have this typical consumer would choose a variety, a variety I, you can say, from a set of N varieties per industry, for a given industry. So this is the problem of the consumer. So in fact, each of these consumers in any given country, importing country, has to maximize a 3-level utility function. So why 3 level? Because you have to choose a set, a variety for each industry. And that's the same thing for a set of industries, and it has the same thing for a set of countries, you know? Because remember that we have importing countries and exporting countries. So, so I'm just writing here that the variety of products goes in the range from 1 to n, right? And both industries and countries have the index from 0 to 1. So this is more or less what we do here. It's the quadratic utility function. And you can see that the first integral from 0 to n just indicates the consumption, or the decision to consume each type of variety, you know, from 0 to 1. And that will correspond to each specific possible industry on each possible exporting country that is indexed by K. So J is the industry and K is the exporting country. And N from 0 to N is the index for the number of varieties that the typical consumer can choose, you know? So indeed we have our budget constraint. The psi just represents the degree of susceptibility or how homogeneous the products are. So again, this is the problem of the consumer choosing varieties across industries and across exporting countries. Okay, so when we solve this, then we get an inverse demand for variety I. You know, we have the lambda is the Lagrangian. And then you can see here that this is the global demand for variety I. And this global demand is what each importing firm will have to face, okay? So you can see that, and remember M, and sorry if I didn't say that, M, the little m, is the number of importing countries. And so integrate over M, and then all the industries in all the countries. Okay, so the supply. We borrow the.
Can I interrupt for a sec? What you're doing everything as an integral, even the countries. Is there an advantage to that?
Excuse me, 1 second. Excuse me.
Well, why not have the countries be discrete, like 1 to 10 or something?
Because it helps my mathematics.
Okay.
Yes.
I have a question.
No, it's normalization, right? It's normalizing, right?
Well, yeah, I don't quite. I mean, it's sort of a special model with a continuum of countries, which one can have it. It wouldn't be. I didn't think you really needed to have that abstraction for this kind of model, but.
Do you mean the K?
Yeah, it looks like the K. Yeah, the exporting countries K and the industries J. They're all unusual to have those as integrals and not summations.
Yeah, because remember that if, let me put it this way. If my data will consist on one exporting country, then I have to drop the integral K, because I only have to consider one exporting country. But in this case, you know, this consumer faces all possible countries that can export computers, right? All type of computers, or all type of cars, or the industry taken into account. So typically, you will not have the K. But since we have exported and imported countries, we face the consumer with a set of product varieties from different industries and from different countries. So you can buy a car, but you can buy grains, and you can buy fossil fuels.
Right, but the way you describe it, it's discrete. So I guess I still don't understand what advantage the integral gives you.
No.
Rather than.
Yes, maybe I misexpressed, but I think from 0 to 1 is to make it continuous, right? It's normal, so it will be the industry 0.001. So it's a continuous from 0 to 1.
Right.
Yes.
Okay, well, maybe we'll see where it pays off,
okay.
but I'm not sure it's going to pay off. So anyway.
Yeah, okay, but we have, okay, let me also mention that so we have a sister paper, right? So that is going to be dedicated just to the theory, because the paper is already very long, you know, so I have to just to mention the main issues from the theory to apply to the empirics. But this, there will be a standalone theoretical paper on this, okay? So, but I will happy to hear your comments and see if I have this right. Okay, so as I was addressing this, we borrow the concept of core competence from Echelanieri, Meyer, and co-authors, in the sense that each firm has a core product.
Okay. This is Andrew McCallum. Can I jump in and ask a question?
Excuse me?
This is Andrew McCallum. Can I ask a question?
Oh, yes, I'm sorry. Yes, please.
So I don't know anything about these types of models or these questions, but
yes.
It seems that one of the reasons we don't like carbon emissions is because it lowers our utility in some sense, right? So do people ever put like the amount of carbon that's in the atmosphere in the utility function, or somehow like, I don't know, let the stock of carbon change the discount rate or something? I just expected to see carbon emissions reducing utility or something like that. Or as far as I understand this utility function so far, it just has goods as usual.
Yes, so I guess that this is a measure of welfare, right? You're talking about welfare measures? Because of how, so I guess you are saying that a carbon tax will create a disutility for the consumer or the firms, or both together?
No, more that like we think that we have this intuitive understanding that carbon pollution is bad for some reason. And so where is that bad going to show up? It seems like it's bad because it lowers my utility or destroys the planet with some probability or does something like that. And so again, I know nothing about these models, but is it common to introduce like, you know, the damage from carbon in the utility function as a negative thing, or?
Yeah, no, this is a partial equilibrium model, so I don't include the carbon emissions in the utility of the consumer or the utility or the profit function of the firm, right? So because carbon emissions is not something that the consumer can directly, maybe a percentage of that. So I do not include, you know, how a reduction in carbon emissions will increase the utility of each of these consumers. So tax will be costly.
Thank you.
Okay, in other words, for the firm, I guess this is the thing. For the consumers, I don't include any advantage or disadvantage of carbon taxes. But the firm, I do have that. So it's a cost for the firm to have this carbon tax. It is reflected in increase in the price in bunker fuel.
But is
because
there
the bunker
any
fuel is going to increase, right?
Is there any
I think the
benefit
idea
in
is you're just not explaining why we have the carbon tax, and I think that's fine. You're just going to say we want to do it for some reason outside the model and then look at the consequences. I think that's fine.
Okay.
Because you could put it in utility, but it wouldn't make it any more interesting. You could just say, okay, this is what we want to do arbitrarily, and then see how to do it.
Yes. So, and as I'm coming out to the situation of the firm, and what the firm will do is to say, well, now that I'm facing a carbon tax, how should I optimize my trade? Where should my goods travel? You know, and of course, I don't have in this paper changes in technology, which is possible to add that element to, right? So the question is, when you are an exporter if you face a carbon tax, would you change your trade structure? Would you change your trading partners, the distance that you will travel? That is what we aim in this paper. You know, it's maybe not tremendously ambitious, but and I guess at the end of the day, I want to say, well, you know, these are the products that are the ones that emit more carbon, you know, and then perhaps address your things about, then we should focus on those products, you know? So that's what I could say. Okay. So now let me go back to this core competence that may be familiar with. So we have, because we have this strategic product, so the firm will say, which one is the one that I have the lowest marginal product? Excuse me, the lowest marginal cost, you know? So the marginal cost increases as my exporting product, my exporting variety move away from my core competence. So there will be, that means that there will be only cost linkages between the products within a firm, right? So, and that I try to implement here. And that's very crucial because, you know, you have different varieties of fossil fuels. Imagine from coal to oil, you know? You know, and I will tell you which industries or products I'm studying here. Okay, let me, this is more important when I do the empirical work. So let me just jump into that. So the supply is, here is we have a typical exporting firm in any industry that can produce a set of product varieties, you know, that is denoted by delta set. And it's going to be exported to a portfolio of countries, you know, located at different distances. And the number of countries, importing countries is M, as I indicated before. So, and this is the objective function of the profit function of the typical firm that denoted by set. So you have this profit function, this the price of the product of type I from industry, for this given industry J. They have the transportation cost, which fuel is a very important part of it. It's almost 50–60% of the transportation cost. Perhaps we face some exchange rate risk. And this C set is the core competence. Yes, so the net price is what is in brackets and multiplied by this, the demand for this particular product. And it's, you see the integral across all the importing countries, the little m that you see there. So that's facing the global demand for this variety I from the specific industry J. Okay, so we assume that these firms play a single Cournot game. Okay, so so we solve this the optimal variety for the typical firm set, you know, that is specialized in producing several varieties of products, you know, to the different partners, trading partners. So when we substitute the global demand, the equation 4, and so do we obtain that this firm set will export? I will explain each of the elements, okay? It's Q on the left-hand side, right? So depends on D. I'll come back in a minute to what is D, on Q and F, right? And I'll explain what is each of these in the next slide. And of course, the Q, whatever this firm set decided to export, depends on the transportation cost. Again, which fuel is an important part of it. Exchange rate risk and this core competence. Okay, so what is D, Q, and F? So remember, this is a Cournot game of the firms, right? So Q is the total output of this firm's set, all the varieties, the sum of all the varieties. The D is the Cournot effect. You know, is all the global demand for the variety I. You know, the global for what all the importers demand for only this variety I. And sorry about that, the numeration is not totally correct. And the F is the global demand for all the varieties that are part of industry J. Okay, so maybe if Samuel becomes a little bit more convinced, what I need is this K and this J. In this case, J is drop out because it's one industry for one industry, one firm for one industry. So you see the integral in F, for example, you have the integral M because it's all the importing countries. And then the next integral is because of all the firms outside set. And then you have the importing, exporting countries. And then you have all the varieties. So as I said, so you can say that this will be what the exporter will decide to do, which is on variety. And this was part of a standalone theoretical paper to solve this. I don't believe we can solve this explicitly, or we have, but we are trying to do this simulate, calibrate this model. We are not so certain yet, but we are working on that. Okay, so, but this setup helps us to understand that what is going to be exported, the Q, depends on the D, which is the total demand, or the global demand, or the the total output from firm set, and the Cournot effect, which is the Q, in the F is the global demand of all varieties. So now, of course, this is what I call the bottom-up, because this is one firm for one specific country, for one specific exporter. So for the empirics, then I just say we can interpret this Q as the total export for one specific country. So the country also specializes in exporting one product. The country also faces competition from other countries for the specific variety. And the country also faces a global demand for all the varieties in a specific country. And the country also faces a quote-unquote core competence, because they are also good in producing and exporting some products and less competent in other products. So if you allow me to go that far, then I will say that the Q also represents the equilibrium for the exporting good variety of the product I. You know, so.
Okay, so Gabriela, before you go on, there's a question in the chat room. Walter wants to know, if you want to discuss maybe the exchange rate risk term, where that's coming from, if there's how you're thinking about that, if it's got a micro foundation?
Yes, so, okay, so each of these, the transportation cost is per unit of product that is transported, right, or exported. So, you know, I guess just how much, remember that this is one product per country, and the P is in dollars, you can say, right? So I have to face this, I have to pay for hedging, you can say. For every product that I export, I have to have some hedging cost. I guess that's the best way to put it. Is that okay? For the, it's a hedging cost.
So I'll just follow up on that just a little
Yes.
bit. It seems like there's a couple other elements to the model that you know, you've got these different preferences. Can you just speak to, like, you know, what you're getting out of all these extra elements? Is it versus, say, the Armington model, which I know you mentioned early on? Is this somehow helping you kind of deal with zeros in the data, or?
Zeros? No, I don't have any zeros in the data. What zeros?
Well, I'm just trying to understand what, it seems like there's a lot of extra stuff versus say like an Armington model. And I'm trying to understand what that's going to get you, or what you're trying to put those things into the model for addressing. So maybe you said it and I missed it, but.
Yeah, no, so you mean that why do we have, you mean talking about this D and Q and F? Or
Well, you know, I think you talked about core competency, you talked about core no, you've got the exchange rate risk.
Yes.
And then you have something about the limited number of who's exporting where. So there's just a bunch of extra features, and I'm just trying to understand what these are motivated by versus just say like writing a standard Armington model. And I must have missed it earlier. So
yeah, because sure, because we have the C-digit product, so the data is at the C-digit product. So I think I can afford to say that there are a variety of products, because the empirical work is at the C-digit level.
okay,
that's the reason. Okay. So first of all, because I have
you can always write Armington at any level you want to, in some sense. So
but they only assume one variety, so that means that they wouldn't have this core competence, right?
No, I mean, you can always have nested CESs, right, all over the place. I was just trying to figure out, is this something where you're getting like you need like a non-constant elasticity or a choke point or something? You know, there's sort of a little bit more extra stuff in this model, and what is it buying you?
Yeah, perhaps when I show the estimates, maybe that will convince you why do we need to do this, because it's you know. So let me to do that, and then I go back to your question, and maybe I'm wrong. So and I'm thinking too much, perhaps, or complicating too much. But let me go to the empirics now, and then maybe I can justify why I make it what it may seem not justifiable, right? Okay, so okay, so we have this, as I said, this solution is a kernel solution with multiple firms, right? So, and you can say, you know, if you think about the computers, you know, many countries that build the computers, cell phones, right? So there are many types of cell phones, and okay, so the data is the width data. Is we have some gravity variables included with the bunker price data, some, and then a key data for us is the data for the carbon emission intensities obtained from the OECD, which specifies what is the carbon intensity for each of these type of vessels, and each type of vessel specializes in transporting different type of products. And then for instruments, we have data on terrorism and backhaul trade from UNTAC. And then we have wave and wind data from Rival and John. So these are the products, the two-digit product that we consider. But again, it's at a six-digit level. The estimations are at the six-digit level, which belong to these industries in column 2 and 3. Okay, so these are why do we choose these products? Because these are the products that have been the heaviest during our period of study, which goes from 2009 to 2016, and they are consistently heavy, the heaviest during those years, yearly, at a yearly basis. So okay, so these are the two-digit, but again, remember that this is a six-digit level study. Okay, so this is the econometric model. And this just reflects some of the theoretical work, you know. So Q is the traded, the amount of trade and per country. Okay, so now we are back. We are now implementing this to our data, which is at the country level. And the Q is the export for variety I, from the Institute J between the pair country K and M. K is the exporter, M is the importer, at time T. Then the distance that this product travels, between K and M. So the right-hand side variables are the bunker price, the exchange rate, and then we have the core competence measure that I will explain how I do this. And then we have this, the total output of that specific variety I for this country. The D is the Cournot effect. How much is the global demand for that variety? And the F is the total demand for all the varieties in the specific industry, in the specific cereals or copper or aluminum or cars or fossil fuels. Okay. So, so hopefully I'm trying to convince George, why do I need all these different integrals and all these pieces of variables? Okay, so let me just skip this for a moment. So we grouped so we have these CDJ products, and we really, let me just at the outset tell you something. So the results tell us that when we started this, I said, well, how is this carbon emission by these categories of products? And we noticed by just plotting some data and doing some simple statistics that the carbon emissions, are very high, are very different across these products. And by simple statistics, we find the elasticities vary according to the value of the product. Okay, so we decided, okay, let's do this in more detail. And for each type of product, we have 4 ranks of values, from the highest to the lowest. So there are 4 categories of products for each CDJ. So that means that we run a regression for each of these ranks, So round 1 will be all the exports that have the highest values in terms of constant dollars of 2010. The second round are the product with the second lowest sales value, and so on, the third and the fourth. Okay, so we ran the regression for each of these groups. And of course, I'm not going to present each of these rounds because I thought it was very important to do that. And for the following reason, I'll show you in a minute. So we found these are the elasticities for each of these industries. Again, this is the effect of the bunker price on the weight and the distance. And if I will have a time to show you how different it is, depending on the value for each of these ranks, is really also very dramatic differences. But let me just show you the average. So you can see that the fossil fuels have the largest elasticity, So, and then the other remarkable things are the vehicles and furniture, But so then what? So what is this figure telling us? So if you look at the 27 and 26, let's see 27. The elasticity is almost 0.5, and say vehicles, the elasticity is 0.01, or excuse me, it's 0.12. It's very tiny, in vehicles. But the vehicles are very valuable. So the red bars are the values per kilogram, And fossil fuels, the value is so tiny in comparison, right? So what we obtain here, is that the response of weight time distance is largest for the products that have the lowest value relative to this weight. And that's what this figure tells us, right? And that is perhaps what George was discussing today, or point out today, that maybe there should be a policy. I need to think about that though, but just at the outset, I can say that maybe this is the way we can address carbon taxation in the maritime sector. Why don't we address fossil fuels and ores? And then why don't we tax less, perhaps vehicles and furniture? And the question, of course, will be, I'm not so sure. Would the community say, well, is that fair? We'll say, maybe it's fair because you are polluting most, right? So maybe this is addressing what George was questioning at the start. Maybe we should address per sector. Okay. But these are the dramatic differences. And most of the studies, they just do the aggregate, So what is the effect of the bunker price or the oil price on the trade? And they give you a number. But there are differences. And then I think that was very important that George raised that question, that maybe we should address per se. So the dramatic part, let me see, I don't want to use my time because I have 8 minutes to go into the government. So the dramatic part here is that the higher the value with respect to the weight, the lowest the elasticity. And of course, when you are the exporter and you say, well, my product value is so little and I have trouble so much, I have to think about how much should I export and where should I bring my product, and that's why I have all this theory that you need to address where to travel, and you need to address how much of each variety, and remember the fossil fuels include coal, which is very polluting. Also, the other thing is that fossil fuels as such, they contribute to 70% of the carbon emissions. So you can say that this is almost shooting two birds with one bullet, right? So fossil fuels are the ones that pollute more in international trade, but also pollute more in general. Right? Okay. So let me go in the few minutes that I have, 7 minutes. So let me show you, what about carbon emissions? Because now I just show you the elasticity. And the carbon emissions, of course, are important to calculate. The elasticities are very important to calculate what will be the impact of carbon tax. So let me just quickly, the tables on the carbon intensities per type of vessels and per type of product. And this is the data that is very important for me to take into account to calculate the carbon emissions per product and per sector. Okay, so if we consider, so we take into account these carbon intensities, we take into account the elasticity, and we take into account a carbon tax. Which carbon tax I'm using? I'm using a $40 per ton of CO2. So this is the lower range what the Stiglitz and co-authors have suggested. It's just a lower range. They expected to have $100 carbon tax. So, and also here, when you have this in place, you have the carbon tax. You take into account what vessels are used to transport each of these 6-digit products. Then you have also that the largest reduction in emissions can come from fossil fuels, as you can see in the figure. Sure. So, and of course, you can ask me, and what trade levels are you assuming? Then I'm assuming an average annual level of that occurred between 2009 and 2017. So if we assume that that this is more or less the trade activity, so this is how much carbon emissions can be reduced today. Okay. Now, let me just because I don't have much time, I need to go. I think this is just a repetition of what I said. Okay. the one point here is that when I say we only study the heaviest products, they correspond to 75% of all the weight in the international maritime transport. Okay, so this is huge part of the transportation cost or the weight. Okay, so yes, so this is the reduction. So this is more or less. I want to go to this number, to this slide. We do some projections for 2050. And why do we do that? Because, as I told you at the beginning, IMO has set some goals on how much they want to reduce emissions. Remember, they are not discussing carbon tax. They are just going to be by using a more efficient fuel, maybe biofuels, and of course, increasing technology. Remember that a boat, a vessel, live for 50 years, right? It takes a long time to replace a boat or a vessel. So they want to reduce 50% of the level of 2008, which is around 550 million tons. So they want to reduce by 50% the 2008 levels. So our estimates, we take into account the OECD table that estimates what will, with advancing the technology on vessels, how will be the carbon emission for each of these type of vessels, for each of these type of products. So we find that 28%, only 28%, there will be only a reduction of 28% of CO2 if we consider a $40 of taxation. We assume that there will be a technological progress in the vessels according to the OECD, and that there was no change in trade. So we say, okay, let's assume that the trade in 2050 is going to be the same than the average between 2009 and 2017. With those assumptions, we obtain only there will be a 28% in reduction of CO2. And the IMO thinks that they're going to reduce by 50%. So that is a little bit difficult to achieve, right? And they are not discussing any carbon, right? So now if trade increases with the COVID-19, maybe they won't increase in the next 2 years, but maybe we are talking far away, 2050. So anyway, this is our results with respect to the ambitions of the IMO. I don't think I have time to tell you about my prices, but let me just perhaps conclude in the 2 minutes I have. So I'm not so sure, but to our knowledge, this is perhaps our paper give a contributing to the literature in measuring how carbon emissions will reduce some kilometers of goods transport in international shipping. As I show you, there could be important changes in the trade of specific products like fossil fuels and ores, an important reduction in emissions. And, there will be a 30 million ton reduction on average if we don't assume that, if we assume that trade will not be affected. And again, the lower the value of the product relative to its weight, the largest will be the reduction in carbon emissions because the elasticities are very big. So in other words, the response of trade to changes in prices or to a carbon price are larger when the value of this product relative to its weight is low. And then my last is this about the fiscal revenues, which can be useful for developing countries. So these are the figures we obtain from our modest $40 carbon of CO2. Okay, I think I used just my time.
Okay, great. Thank you, Gabriela. So we'll open up the floor to questions, comments, and remarks. And I'll use my moderator's privilege to go first.
Yes.
So it went a little fast when we got to the econometrics part. What exactly is the identification here? And I'm asking this in the context of what sort of like time horizon do you think these elasticities are sort of hitting? Are these?
This is the average from 2009. The data goes from 2009 to 17, right? So the answer to your question is, all these results depends on that, assuming that an average trade or a trade activity, annual trade activity that corresponds to what happened between 2009 and 2017. Is that answer the question?
Sorry, I think that's close. So let me just make sure I understand. So this is, so say that again, it's 2000 and...
Yeah, the data, it goes from 2009 and 2017.
So it's those 2 years? It's the 2 years, 2009, 2017?
No. From 2009
every year.
2017.
So it's the annual variation in the cost of the fuel that's kind of identifying this elasticity?
Yes.
Okay. So this is like a pretty short run elasticity, I guess. So are you kind of picking up like the lower bound maybe, if you think they're like, longer term, that the elasticities get bigger over longer time horizons?
Yeah, no, I have not measured that. I guess to do that, then I have to introduce some kind of lag, right?
I guess, yeah. I mean, even just theoretically, I guess I just want to make sure. First, I just wanted to make sure that I had this correct. That you're picking all this up off the annual variation in prices.
Yes.
And then the question would just be, if you put this tax on and waited for 10 years, would you get a lot bigger response than you would for just a year-to-year fluctuation in prices?
The way I would put it is in the following. Say for the 50, I showed you some prediction for 50, right? So you say, well, imagine, maybe we shouldn't think that far because it's so far away. Say 2030, right? Which I also calculate. Say 2030. You say, okay, let's impose a tax in January 2030. So what do you need? You say, well, what has been the trade activity perhaps up to 2029, right? So, and then you need the carbon intensity for the vessels. And to calculate the 2030 and 2050, we say, well, assume in 2029, the trade activity is the same activity that happened between 2009 and 2017. So no change in trade. So, and then what is the elasticity for that type of activity occurring those days, those years? Then I have this elasticity. So whether we call it maybe you can call it a short run, but this elasticity that we obtain to measure the response, right? So I guess to the long run we need a lag, and that has so few years that I cannot afford too many lags, unfortunately.
Sure. No, I'm not saying that what you're doing is wrong. I'm just trying to think about this longer thing. Yes. You kind of said like ships, it takes a long time. Ships are really expensive. You don't just throw them away.
Exactly.
So, it would, that would certainly slow things down, right? These investments in trading technology.
Sure. But this carbon intensity per vessel, they are approximated. They say, for example, this table that I show you, these are estimates moving from 2010 to 2015, and then 2020, 30, and 50. So it takes into account the long. So this table is the only one that takes into account long-run effects and the technology progress of the vessels.
And just for my own curiosity, why are vehicles so intensive in carbon? What are they doing? Are they going fast? Are they using really small ships? Why is that so nasty compared to the rest of them?
The vehicles is because of the type of vessels they use. Maybe they go too fast because yes, I don't have the time to explain. These carbon intensities take into account the speed, the weight of the vessel. So yes.
Okay.
Yes.
But picking up on Kim's point, I'm worried it could go the other way because the oil price, when there's a big recession, like in the Great Recession, trade plummeted, but the price of price of oil would have plummeted as well because nobody really wanted it. And then that would make it look like they were trading less because of the price. Let's see, have I got that wrong? Because then I guess they're trading less when the price is low. Anyway, it's something to think about.
They trade more when the price is low, right? They trade more when the price is low. Is any
yeah. In your story, yeah. So maybe that doesn't. I'm surprised that doesn't lead you to get coefficients going the other way. I guess then that.
Which other way?
It seems like in the data you would find that when the price of energy is low, those would be times when trade would be low. And yet your story is kind of the other one. I think, yeah, I mean, your story is perfectly sensible. I was just worried about what the variation in the data, sort of like Kim posed it, what is the identifying assumption, which is that the price of energy kind of moves around in a way that's not correlated with trade shocks.
Yeah.
But now I'm realizing my story wouldn't lead you to get lower elasticity. But another question or point, I think I kind of read your table as saying, well, if there was a big tax on using energy and shipping, we probably wouldn't bother moving coal around. That would just be a silly thing to do because it's not very valuable and it's heavy. So just keep it wherever it is. Don't trade it anymore. And I think that's kind of what your results were saying, right? That big heavy stuff, you just
trade less and to shorter distances, right? Or consume
yeah,
less.
right. Yeah. So maybe we'd still ship coal to Mexico, but it wouldn't be shipped anywhere else or something like that. And I think that makes a lot of sense, but you're sort of focusing on only that part, right? As opposed to, you don't have a carbon tax on the use of coal, you have a carbon tax on the movement of coal or the movement of anything else.
That's right.
And then you're saying that vehicles it's still worth importing German cars, even if there's a big carbon tax on shipping because they're so valuable and maybe the amount of energy used in shipping them isn't that big a deal. Is that a fair interpretation of what you're
right. That's
saying?
Right.
Okay.
That's correct.
But I don't think that has implications for how we should tax carbon. That's just saying the consequences if we taxed it, because you want a uniform tax because that's optimal to the tax should be based on how harmful it is, and the harm is the same whether it's shipping coal around or shipping Mercedes-Benz around. So I think there should be a preference for a uniform tax, but then I think what you're showing is the way in which a uniform tax would then have different consequences for trade in different types of goods.
Yeah, that was a little bit what George was pointing out earlier, that maybe we should say, well, we have a uniform tax, but in addition, we have an extra tax for the most polluted ones, right? Or the ones that are heavy, low in value.
Well, but I think that'll happen automatically. That if there's a tax, then you'll stop shipping coal. And so the market will kind of do the right thing then.
That's true. There will be a dynamic effect, right? So yes, probably that's true. Yes. So, but I don't know if at the end of this, I convinced you that it was good to have this a little bit, maybe that apparently may look unnecessary to have all this.
I agree with George on the Armington model. I mean, I would follow like the Goldberg-Feigelbaum paper on the Trump's tariffs. I think that's a really nice use of the Armington model with a lot of detailed data, and that way it's very conventional, and so the emphasis on your results rather than on the methodology.
Yes. What was the name of the paper again? Could you tell me?
Oh, Penny Goldberg, and what is the name of that paper, Kim or George? You remember?
The return to protectionism.
Yeah, that one.
I see.
Because that kind of uses that framework, I thought, in a fairly straightforward way. But
Yes. Okay, I'll take a look at it. Maybe my head was thinking too much, and maybe I should make it simpler.
Let me follow up just for a second, which is, I mean, I think what you're trying to identify is the elasticity to a change in trade costs, right?
Yes.
And then, you're using these bunker fuels because that's maybe like the type of trade cost that you're thinking about raising. But in some sense, like the typical elasticities that we see to a change in trade costs you could always kind of apply them to each of these products because, coal might have a really high trade cost, and we know the elasticity of tariffs to trade costs. You can do your calculations almost exactly. And so I would sort of think about like how different your response is, or your estimates would be by using kind of the conventional methodology, which uses, cross-sectional trade costs or tariffs, and then scales them into, what change in shipping costs you're converting, and then what your approach yields, and see if they're somehow consistent.
Yeah, you mean that to include the transportation cost?
Well, I mean, like, some
goods have like to have instead transportation cost.
Some industries, some goods have a 10% transportation cost, and adding $40 to the shipping cost is going to raise it by, is going to double it, and some ones it's not going to change it at all. And so I think that's kind of what you're picking up, but then you have a lot more data that you can kind of use to estimate.
That's true. I can tell you because it was one of your colleagues was present at the very beginning of these seminars, and I had all of the data on transportation costs. It's a lot of work to do it at a 6-digit level. So, but I got the data from the OECD. So and that was my goal to test and say, well, I have this for the bunker price. What about the transportation cost? So I have my data. I think it was George Kolakis. Yes, but anyway, so
I guess to kind of defend George, I mean, I guess I would defend what Gabriela is doing on that sense, in that the policy would be like very close to raising the bunker price of the fuel. I mean, that's the nice part of it, is it sort of makes the empirical work line up pretty well with the intervention being considered, which would be something that would raise that price of that bunker fuel.
Sure. Yeah, I think the only thing I'd be concerned about with the bunker fuel, aside from the point that you were talking about, the business cycle aspect, is you don't have to get bunker fuel at every port you stop. If the ship is full, you might just fill up over here before you go. Like it used to be when I would drive from New Jersey to Philadelphia, I would fill up my car when I left New Jersey, right? Before I got to Philadelphia. And so you might have this substitution that's not exactly right. Listen, I think it's a direct measure. This is just something to see if your estimates line up with the more traditional way of doing it.
That what is a little bit important to this issue of because in New Jersey is cheaper than gasoline, right? So and that is the reason why you need to have a global carbon tax. You cannot have let this country to do that and know that. Then all the boats we're going to go to the place where there are not carbon tax, right? Sure. So it needs to be global, right? But I can confess you, I did attempt to but I will perhaps do in another paper the position cost, but it is a lot of work to this data to do it at a detail, at a 6-digit level. So, and it's not complete either, but we'll see. But I hope you are a little bit happy with what I have done.
Great.
Yes.
Thank you.
Okay,
thanks so much.
Thank you so much for having me. Thank you. Thank you for the comments. Okay.
And we'll see everyone next week at 3. Oh, sorry,
yes.
Kim's in charge. We'll see everyone at 3 p.m. next week. So we've made the change.
Yes,
so.
I'll remember that. I will remember
All right,
that.
everyone.
All right. Okay. All right. Thanks, everybody.
Thank you.
Bye.
Bye-bye. Thank you.
Bye.